Hello everyone, welcome back. Remember, we were talking about the different structures that you can use to represent organic compounds. And those structures were the expanded or sometimes Lewis structures, condensed, and line structures or skeletal structures. Okay, and we are picking up with example C, where we're asked to give the molecular formula. Remember, that is carbon and the number of carbons and the number of hydrogens and any other heteroatoms that exist. And the first thing that we did was first determine where the carbons are located in this structure and turn it into an expanded so that we can count up the number of hydrogens. And a carbon is located on every end and every corner. Now, one thing that might be interesting about this structure is notice how in between this triple bond there's not technically a corner, but there is a carbon there on the other end. And then there's a carbon on every corner and every end. And so if we number them from left to right, we've got 1, 2, 3, 4, 5, and the sixth one at the bottom. So already found that we have 6 carbons, and we simply need to determine the number of hydrogens, remembering that every carbon has to have 4 bonds. So that first carbon already has 3 bonds from the triple bond. So carbon number 1 only needs a single hydrogen on the other end. And then for carbon number 2, notice how it already has 3 bonds to the left from the triple bond, and it has a bond to carbon number 3. So it has a total of 4 already and does not need any hydrogens. Now from carbon number 3, looking at carbon number 3 on either side, we have 2 bonds, one on either side, meaning that we need 2 hydrogens, one on top and one on bottom. Carbon number 4 has a bond to carbon number 3, a double bond to carbon number 5, and it has a single bond to carbon number 6 underneath. So it already has 4 bonds. Okay? So carbon number 5 has a double bond to carbon number 4. So therefore it needs 2 more bonds. It has a double bond to carbon number 4 and needs 2 more to give it a total of 4. And then carbon number 6 only has a single bond going up to carbon number 4, and therefore it needs 3 hydrogens. Okay, so if we add these all up, we have 1 from the first carbon, there's 2 on carbon number 3, there's 3 on carbon number 6, and there's 2 on carbon number 5. Okay, so that gives us a total of 8. And therefore we get C6H8 for our final answer. Okay, the next set of examples, we are asked to give the condensed formula for each of the following. So remember, that simply means that we do not show the bonds to the hydrogens. Instead, we package them together. And so looking at this first structure, we have 1, 2, 3 carbons. The first carbon has 3 hydrogens attached to it. And so therefore we want to label that as CH3. Okay, the second carbon has 2 hydrogens. And so therefore we're going to label that as CH2. The third carbon has 2 hydrogens. And so that is CH2 as well. And then the fourth one is a nitrogen with 2 hydrogens attached to it, which becomes NH2. And sometimes you will see the condensed formula simplified even further, where if you type in an answer, you can simply say CH3, CH2, CH2, NH2. Okay, both of those are acceptable condensed formulas, but typically if you were typing in an answer, the second is the more likely. Okay, in example B, we're given the skeletal. So the first thing we want to do is find all those carbons. We know carbons are going to be on the end, unless there's already an atom shown, like that chlorine, and then a carbon at every corner. So we have a total of 1, 2, 3, 4, 5 carbons. Okay, the first carbon has a bond to carbon number 2, and that's the only bond that's shown, and so therefore carbon number 1 needs 3 hydrogens to give it a total of 4, and we can show those by simple lines sticking out on the skeletal structure. Okay, so that first carbon needs 3 hydrogens to give it a total of 4 bonds. The second carbon already has 1, 2, 3 bonds attached on either side. From that double bond is 2, and on the left makes 3 from the single. So it needs only 1 hydrogen to give it a total of 4. And therefore carbon number 2 is CH. Carbon number 3 has a double bond on the left and a single bond on the right. So it has 3 bonds already, and therefore carbon number 3 only needs 1 hydrogen to give it a total of 4. Carbon number 4 has a single bond on either side, and it has a bond to chlorine underneath. So let's go ahead and draw in that chlorine. Okay, the chlorine we're going to show underneath as a single bond, and that carbon has 3 bonds total, and therefore it needs 1 more hydrogen coming off the top to give it a total of 4 bonds. And then that's bonded to the last carbon, and the last carbon is at the very end. So if a carbon is singly bonded at the end, it needs 3 hydrogens to give it a total of 4 bonds. So each time you're adding in those hydrogens until every carbon has 4 bonds. And I forgot, the second and third carbon, there should be a double bond there. Okay, and again, you could condense this even further by simply typing CH3, CH, 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 and then that Cl kicks up in between, Cl, CH3. Okay, the last example is again a skeletal, and therefore we need to locate those carbons. We should have 4 carbons going across and 1 underneath. Carbons 1, 2, 3, 4, and 5. Okay, the first carbon is at the end, so it needs 3 hydrogens to give it a total of 4 bonds. The second carbon already has 3 bonds from the oxygen and on either side. So therefore it only needs a single hydrogen. We're going to show the oxygen above with its hydrogen. And again, you don't show the bond between the oxygen and the hydrogen. And then going on to carbon number 3, it has 3 bonds as well, and therefore only needs 1 hydrogen. And then carbon number 4, the one on the far right, needs 3 hydrogens because it's on the end. And carbon number 5 is also at the end of a line and therefore needs 3 hydrogens. Okay. Our next set of examples, we are asked to give the skeletal formula for each of the following. And the first one, they're giving us the molecular formula. So we're going to assume that we're dealing with straight carbon chains. And in the question, it should tell you that this is a straight chain. And so remember that as I start my straight chain, that at the end of every line is a carbon. So there's carbon number 1, 2, and then if I keep going across, 3, 4, 5, and 6. Okay, so as long as I count up, starting at the beginning of the line across, I should have 6 carbons, and then all the hydrogens are assumed. So my final answer for that structure should simply be 5 zigzag lines. Okay, for B, it may help to draw some dots at every carbon so that we can make sure that we have that many when we're done. Okay, so starting at the top and tracing each one of the bonds, I have a carbon, carbon here, here, and here. Okay, so my structure should look very similar to the beginning, just taking out those carbons and hydrogens and leaving the bonds. And then underneath I have a bromine. Okay, and then drawing it without the dots, which is the way you want your final answer to look. Should look something like this.